In this video, we are going to be solving linear equations that involve one step. So when you're solving a linear equation, the goal is to get the variable all alone on one side of the equation equal to the constant. So your variable is your unknown, your letter, your x, your y, your z, equal to a constant being a number, -5, 0, 1/4, 12. So an example would be x is equal to 5. When I get to that point, I've reached the goal in solving an equation. So the first equation that we're going to solve is x plus 8 is equal to -3. So one thing that you can do that will help you is to draw a line down the equal sign. And keep in mind, whatever you do to one side of the equation, you have to do to the other, because an equation is just a balanced statement. So you always have to be fair. To isolate the variable, you're always trying to undo what's being done to it. So for example, when we have x plus 8, we're adding 8 to our variable. So to undo adding 8, we would subtract 8 from both sides. So on the left side, we want to make sure that the two numbers or the two terms are opposite of each other so that they undo each other. And plus 8 and a minus 8 zero each other out. And then we want to make sure that we've done the same thing on both sides of the equation to be fair. So after we subtract 8 from both sides, we're left with x is equal to -3 and a -8 give me -11. So my solution is -11. Now you don't necessarily have to do this, but just so you have an idea, to check my solution, I would just plug in the value of x into the x, and so my value is x is equal to -11. So I'm going to plug -11 in for x, plus 8 is equal to -3. When I combine like terms on the left side, and -11 plus 8 is -3 equals -3. Because I got a true statement, I know that x equal -11 is the correct solution. So that's how you check, is just by plugging in your value for your variable and making sure that you get the same thing on both sides of the equation. Problem number 2, -10 is equal to x minus 4. So here, my x is having 4 subtracted from it. So the opposite of subtracting 4 would be adding 4 to each side. So the -4 and the +4 undo each other, or zero each other out, leaving me with x is equal to -10 plus 4 is -6. So my solution is x is equal to -6. Problem number 3, -4y is equal to 36. So a vocabulary word here would be that -4 is what we call a coefficient. A coefficient is the number that we're multiplying our variable by. So we're multiplying -4 times y. So the opposite of multiplying by a -4 would be dividing by a -4. So I'm going to divide both sides of my equation by -4. Well, on the left side, -4 divided by -4 leaves me with a +1, which I don't have to write. You can if you like. I'm not going to, but it leaves me with y is equal to 36 divided by -4 is -9. So my solution is -9. And again, you could check it. If I plug in the -9 for y, I'd have -4 times -9 is equal to 36. When I multiply the left side of my equation, I get 36 is equal to 36. Because I got a true statement, then I know that my solution is -9. Number 4, we have 2x is equal to 5. Once again, 2 is our coefficient, and it's being multiplied by x. So to undo that multiplication, I would divide both sides by 2. So 2 divided by 2 leaves me with 1x, and then 5 divided by 2 can't be simplified. So I'm going to leave it as an improper fraction. An improper fraction is when your numerator is bigger than your denominator. I can't reduce it in any way, and I don't need to write it as a mixed number or a decimal. I'm just going to leave it as 5 over 2. And my last problem, x divided by 8 is equal to -2. So what's happening to my x? Here it's being divided by 8. So the opposite of dividing by 8 is multiplying by 8. So I'm going to multiply both sides of my equation by 8. Well, 8 divided by 8 on the left side cancels, and that leaves me with just x is equal to 8 times -2 is -16. So my solution is -16. So again, our goal for solving an equation is to have x isolated on one side of the equation equal to a constant.